So welcome back friends. Motion in a straight line. This is our next chapter for 11th class. Till now we completed our first lecture and we are now moving towards the second one. And this is what our next chapter, motion in a straight line. So if you see the motion in a straight line, we take an example of ants. They are moving in a straight line always. Why do ants move like that? Would you have any, you can say sometimes, no, sorry for discontinuity. So motion in a straight line, we will study like on a road, cars are moving in a straight path and ants are following one another without any distractions. And if you see, a swimmer can swim while racing in a straight path within this limited space. So this is what kind of a straight line motions. Okay, so we will take an example of a cheetah when he is running and he want to catch a antelope, so he is also running in a straight path. So such kind of straight line motions we will learn in this chapter. So we will move to the next. So we have some kind of questions in our mind like what distance must an airliner travel down a runway before reaching takeoff speed? Okay. Second question, when you throw a baseball straight up to the air, how high does it go? So one more question, if you can imagine when a glass slips from your hand, how much time do you have to catch it before it hits the floor? So these are the kinds of questions you will learn to answer in this chapter. So we will study such a small sort of concepts to answer such questions in our mind. So we are beginning our study of physics with mechanics. So we call this as a classical mechanics as well. So the study of the relationship among the force, matter and motion we will study in this chapter. So in this chapter and the next we will study kinematics. So we call this as kinematics, the part of mechanics. So this is the part of classical mechanics that enable us to describe motion. Later we will study dynamics. So first we will study kinematics and after we will go to the dynamics, so which relates the motion to its causes. So motion we will study and cause for the motion we will also study. So in this chapter we concentrate on the simplest kind of motion. So there is the straight line motion. To describe this motion, we introduce the physical quantities velocity and acceleration. So we will study what is velocity and what is acceleration in this chapter. So in physics, these quantities have definition that are more precise and slightly different from our ones used in our day-to-day language. Okay, so these are slightly different in our day-to-day language. So you see, our first article in this chapter is position, path length and displacement. If you will see what is the position. So earlier you learned that the motion is change in position of an object with time. So what is the motion? Motion is nothing but the change in position of an object. So if you are there in your house, now after some time, so you are there in your school. So that's the object is as a you as a person, and now you are changing your position from home to the school. Now you are changed your motion from one place to another place with some time. So position, change of the position of an object with some time, so we call it as some kind of motion. So in order to specify position, we need to use a reference point and a set of axes. So this is what the position, and this is what somewhat axis we need. So we will have some xy kind of axis. On that, suppose a object is moving from this place to this place, so we consider this as north, south, so east and west. So now if an object is moving from east towards east, and after that it is moving towards the north side, so we can say this is moving in particular axis. To understand, to study the object motion, we consider this as a rough motion, or we can say a rough reference point. Okay, now it is convenient to choose a rectangular coordinate system consisting of three mutual perpendicular axes labeled as x, y and z direction. So just now we saw this is what we call them as xy axis, as you already know, that is this is y axis, this is negative y axis, this is positive x axis and this is negative x axis. So like this we will consider, and one more axis we will consider, that is z axis in three-dimensional way. So now the point of intersection of these three axes are called origin. So this is what the origin point, where all these three points x, y and z are there in the center. So you can say this as the interaction of these three axes are called origin. So we call this as origin, and serves as the reference point. So we take it as a reference point. So if suppose the object is moving towards the x-axis, we measure that value is from this origin point. Okay, now the coordinates x, y and z of an object describe the position of an object with respect to the coordinate system. So we call this as coordinate system. So this is nothing but the coordinate system. To measure time, we position a clock in this system. So this coordinate system along with a clock constitute a frame of reference. So this is nothing but a frame of reference. So if you are imagining something is to be put in this frame. So suppose there is a C in this frame and we want to measure a position of this fish from this to this when it is to be moved. So we will take a reference point over here as the origin and we will measure its motion from this point to this point. Okay. So move to the next slide. We will see what is the path length. Just now we studied what is kind of motion, what we call it as a motion. Now we will see the path length. So we have a line over here. On that some numbers are to be written. Some are towards the positive x-axis and some are towards the negative x-axis. And if you see, this is the origin point. So this is what? 0th point. So this side all are positive values and this side all are negative values. Now consider the motion of a car along a straight line. So suppose there is a car over here and it is moving along a straight line. So we choose the x-axis such that it coincides with the path of the car's motion and origin of the axis. At this point where the car start moving, the car was at x equal to 0 and at time equal to 0. So car is here and now it is starting to move when this x position is 0 with the time equal to 0. Now we will start our stopwatch and we will measure how much distance, how much path that car is to be covering from this origin point. Suppose this is your house and this is your school, and if you want to move from here to here, you have to cover some kind of path. That path is nothing but you start from your home, that is distance equal to 0, that is your origin value, and with time equal to 0. So that means if you need 10 minutes or 15 minutes to reach your school, that is your final time, and final path distance is nothing but the distance between your school to your home. So now let P, Q and R represent the position of the car at different instants of time. So here we will consider some P, Q and R position. So this is what this is what P, this is what Q and this is what R. So we are considering three different points on the three distance time. Now consider two cases of motion. In the first case, the car moves from O to P. In first case, we are moving this car from this O to P. So now this is what the P and this is what the O. Now we are considering this first case. Then the distance moved by the car is OP and that is nothing but 360 meters. So if you see here, this is 360, so 360 meter. This distance is called the path length traveled by the car. Now in the second case, the car moves from O to P. Now again, the car is moving from O to P in second case, and after that it is moving back to P to Q. Now after this it is moving from P to, so Q is still here. Okay, so Q is still here. So this is what the extra path after this P distance. So P is initially 360 plus 100. So how much it is? So 120 till here. If you see 360 minus 240 you do and you get to 120. So total distance traveled is nothing but 480 meters. It is nothing but OP plus PQ, total distance traveled by the car. Now the path length is a scalar quantity, that is it doesn't have any direction. So quantity have magnitude but no direction. So you understood the path length. Now we will study what is the displacement. So path length just now we studied. Now we will see what is displacement. So what is distance? So to understand displacement, we are supposed to know what is distance. So distance is the total movement of an object without any regard to direction. So we can define distance as to how much ground an object has covered despite its straight or ending point. So suppose there is a house. So an object wants to go from this point to this point, and after that this point, and after it is stopping over here. So total distance traveled by the object is nothing but this much. So whatever the direction, it doesn't matter to us. So total distance is nothing but whatever the road you cover to go from one place to another place without any direction. So that is nothing but the total distance covered. Now specifically we will consider some kind of distance in the direction. So this is what the straight line, shortest path. So this shortest path we call it as a displacement, and the whatever total distance covered is we call it as distance. So properly understand the difference between distance and displacement. Distance is nothing but the path length. Distance is also known as path length. So path length is the total path covered by the object, and displacement is nothing but the shortest path covered by the object. So displacement is nothing but the vector quantity, and distance is nothing but the scalar quantity. So keep it in your mind. So distance here will be 4 meter plus 3 meter plus 5 meter. So if you see 4 meter, 3 meter and 5 meter. So total distance covered. Now what is the displacement? Displacement is nothing but from this point to this point. So A to C is nothing but our displacement. So for example, if an object moves from A position to B position, then the object position changes. So this change in object of an position of an object is known as displacement, and this is what the distance, and distance formula is nothing but the change in distance is nothing but d1 plus d2. So total distance covered. Okay, now see the displacement formula. Displacement formula is also, we will write it as change in displacement. So it is nothing but the final distance minus the initial one. So if you see the distance, it is d1 plus d2, and if you see the displacement, it is with negative sign. So displacement and distance have one formula, one difference in the formula, that is it is with negative value, negative sign, and distance is with positive sign. Okay, so now final position minus initial position will gives you the total displacement. So xf is nothing but final position, and x0 is nothing but the initial position. So if you do final position minus initial position, you get the displacement, and the total distance whatever traveled by the object d1 plus d2 plus d3, and it is so on. So we call combining it as the total distance covered. Okay, now if you see, a boy is traveling so much, and what is that? After that he is reaching some point, final point and the initial point. So this is what his initial point, and this is again what his final point. So if you see, the displacement is 0. Why? Because that boy have traveled this much. So this is what the total distance or the path covered by the object. But the displacement is 0. Why? Because there is no change in position. If there is a change in position, yes, that is the displacement. So that object is coming back to the same position, so there is no change in the position, so therefore displacement is 0. So we have to take some cautions while learning distance and displacement. So the meaning of delta x, note that it is not the product of delta and x. It is the single symbol, that means the change in the quantity of x. Okay, so we always use the Greek capital letter delta to represent a change in a quantity. So whenever this delta comes, it is representing change in that quantity, whatever written front of the delta. So equal to the final delta represents the change in the quantity, which is equal to the final value of the quantity minus initial value, never the vice versa. In the sense, this is never reversing. It is not like initial minus final. It is always final minus initial, that you keep in your mind. Okay, same way we have to take the time. It is also final time minus initial time. It is not like initial time minus final time. So keep it in your mind. Now we have to check a numerical to understand this distance and displacement. So John travels 250 miles to north. So we will consider diagram. So where this is north, south, east and west. So John travels 230 miles towards north and but then backtracks to south for 105 miles. So he traveled 250 miles and after that he is coming back to 105 miles to pick up a friend. So what is John's total displacement? So total displacement is nothing but the final minus initial. So final is what 250 and the initial is 105. So don't get misconfused that how that fellow is traveled from this origin point to here but he reached over here. Now this is what the final one. Okay, he is coming back to somewhat middle point. So to pick up his friend, so that whatever displacement is there in this point, so that is what the difference between this point to this point will gives you the total displacement of the object. So, okay. So now one more example is there, one more numerical we will solve. An object moves along the grid through point A, B, C, D, E and F. So object is moving, so these are the grids. So object is moving from A to E as shown in the figure. So the side of square tiles measure is 0.5 kilometers. So this is what the 0.5 kilometers. So this is nothing but the 1 kilometer. So this total is 1 kilometer. Now you are asked to calculate the distance covered by the moving object. So you have to calculate all these like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 grid covered. So one having grid value 0.5 kilometers. So if you multiply all these 13 number of grids into 0.5, you will get the value of total distance covered. So if you see AB plus BC plus CD plus DE plus EF. So how many A to B? A to B we have 1, 2, 3, 4, 5, 6 grids. And after that B to C. So B to C we have 2 grids. After that C to D we have 1, 2, 3 grids. And after that D to E we have 1 grid and E to F we have 1 grid. So when you multiply this you will get the answer 0.6. So you are look at here it is to be given 3 for AB. It is like 1 kilometer. This is 2 kilometer and this is what the 3 kilometers. So 1, 2, 3 like this it is to be written 3 over here. If you see BC, B to C we have 2 grids that one having 0.5 value. If you have 2 grids so that means it is having total 1 kilometer. So therefore in place of BC it is written 1. Now CD having 1.5. So CD is nothing but 1, 2. So this is what the 1 kilometer and this is 0.5 kilometers. So total we have 1.5 kilometers. So for DE it is 1. So therefore 0.5 and for EF also it is 0.5. In place of like this you can write also like this. So 13 into 0.5 you will get the total answer here also 0.5 kilometers. Okay. So total distance covered is nothing but the 615 kilometers. Now find the magnitude of displacement of the grid, of the object. So now we will see next part of this. The initial point is nothing but A and the final point is F. Hence the magnitude of displacement is equal to the distance AF which is calculated by applying Pythagoras theorem. Okay, so we have to calculate this distance. To calculate this distance, we have an imaginary line from F to the straight line AB. So here we are naming this point as H. So it is looking like a right angle triangle. So to solve right angle triangle, we use a theorem Pythagoras. That we know that AF square is equals to FH square plus AH square. So if you see 1, 2, 3, 4 grids are there. So 4 into 0.5 will gives you AH value and 1, 2, 3. So 3 into 0.5 will gives you FH value. So if you calculate these two and make their squares. So you can calculate the value, that is nothing but the displacement. So don't forget to put the square root and calculate the square rooted value. If you simply add and put, this is not the correct value. Okay, this is what the correct value when you make its square root of the value, and after that you will get the value as 2.5 kilometers. So the displacement is nothing but the 2.5 kilometers. So always keep in your mind that displacement value is always less than the total distance covered. If you see the distance, it is 6.5 kilometers, that is the total path traveled or total path length, and the displacement is nothing but the 2.5 kilometers, that is the shortest path traveled by the object. What is the difference between distance and displacement? The complete length of the path between any two points is called the distance. So this is what the total distance traveled by the object from start to end. What is the displacement? Is the direct length between any two points when the measured along the minimum path length between them. So this is what the straight line. So if this is the Mumbai and this is the Goa, you have different ghat areas and you have to make round and round trips to reach the Goa. But if you have direct flight from here to here, this is the direct route from Mumbai to Goa. So to travel this much big path, you call this as distance. But if you travel from here to here directly, this is the shortest path, so that we call it as displacement. Okay, now distance is a scalar quantity as it only depends upon the magnitude and not on the direction. So distance has no direction, but it has only magnitude. So displacement is having both vectors quantity, and this is both having magnitude as well as direction. Since it is having direction, we call it as a vector quantity. It is not having the direction, we call it as a scalar quantity. Now distance can only have positive values always. Displacement can have positive, negative as well as zero value. Okay, distance always positive value, displacement are positive, negative and zero also. Positive, negative as well as zero also. Now distance is a scalar quantity and displacement is a vector quantity.